In Lesson 6.7, we're going to transition from modeling with algebra tiles to add and subtract polynomials to recognizing like terms in an expression. There are two things that we really have to look out for when we're combining like terms. First of all, like terms have exactly the same variables raised to exactly the same powers. Only like terms can be simplified. The second warning is just a reminder that exponents represent repeated multiplication, so exponents will not change when we're adding or subtracting terms. In our first example, we want to add the polynomial x squared plus 7x to the other polynomial x squared plus 8x plus 4. Since we're adding these two polynomials, we can drop the parentheses because there's nothing to be multiplied by them. So it won't change anything if we just drop the parentheses. So x squared plus 7x plus x squared plus 8x plus 4. And that's what we have modeled here. You can see that we have two x squares, and it's easy to see in the models because they're blue squares and they look the same. If we look at our list of terms in our polynomial without the parentheses, we can see one of our x squares right here and the other one here. The way that we recognize those are like terms is that they're exactly the same variable raised to the same power. We have two of them, so we write 2x squared as one of our terms. In our picture, we can see that we have 7 green rectangles on the left that represent our 7 x's. And in the next expression, we have 8 green rectangles which represent our x's. So altogether, we know we have 7 plus 8 x's, or 15 x's. In our list of terms, we can see that 7x right here and the 8x right there. We know those are like terms because they have exactly the same variable raised to the same power. Remember that understood power is 1, but we don't have to write that 1. We know if it's just x, then it's x to the first power. Now I still have these 4 units. My first polynomial didn't have any units, and the second polynomial had 4 units. So we need to bring down those 4 units. This is the simplified polynomial that represents all of those shapes. Now let's think more abstractly, which means we're not going to model the polynomials that we have below. When our powers get bigger than a square, then it's much harder to model them because instead of having 2 dimensions, which is on a flat surface, we would have to have 3 dimensions for this 6b to the 3rd power. And if our power gets bigger than that, we really can't visualize more than 3 dimensions. So that's why we need to use the algebraic process from our prior example to figure out how to combine these like terms. My first polynomial is 2b plus 7. I don't need the groups because I'm adding, so I'm just going to drop the parentheses. My next polynomial, 6b to the 3rd plus 9b squared plus 3b plus 3. All I've done is drop the parentheses. Now I'm looking through the list and I want to find the like terms. It's a common practice to write your highest exponent first, so I'm going to do that. That is not required, but since it's usually written that way, that's what I'm going to do. So I'm looking through the list and I see 6b to the 3rd is the highest power of b, and there are no other b to the 3rd power. So I know I'm going to have 6b to the 3rd in my final answer. Again, I look through the list, and my next highest power is b squared, and there are no other b squares. So my final answer will have 9b squares. These cannot be combined because even though I have the same base of b, I have 6b to the 3rd power and 9b to the 2nd power. If the exponents are not the same, they're not like terms, and they can't be added any further. Now I'm looking through the list, and I see I have 2 b's right here, and I have 3 b's over here. So if I have 2 b's and I add 3 more, then I have 5 b's altogether. Then I look at my constants. There's a 7, and then there's a plus 3. 7 plus 3 is 10. And this is my simplified polynomial addition. In our next example, let's look at subtracting polynomials. It's very similar to adding polynomials with one additional step. Adding a negative is the same as subtracting. So instead of subtracting 4x plus 2 from the original polynomial, I can add the opposite of 4x plus 2. So I'm going to change this minus to a plus, and I can do that by taking the opposite of each of these shapes. So these are going to be negative x's instead of positive, and these are going to be negative 1s instead of positive 1s. Now every time I have a negative x and a positive x and I combine them, I get 0. This negative x and this positive x, this one and this one, this one and this one are going to cancel each other out. The same thing happens with the units. A negative 1 and a positive 1 gives a 0 sum. This negative and this positive will cancel out. So what I'm left with are 2 x's and 6 units. Here's what that looks like when I'm only looking at the expression. The first thing I want to do is change this minus to a plus. But to do that, I have to take the opposite of what is in the group following the minus sign. So I'm going to drop the parentheses in the first group, since there's not a negative in front of that. And then I'm going to add the opposite, so plus negative 4x and minus 2. One way to think about this is distributing a negative through the parentheses. So now I can drop the parentheses on the second group. Adding negative 4x is just subtracting 4x. Adding negative 2 is just subtracting 2. And now I look for my like terms. If I have 6 x's minus 4 x's, then that leaves me 2x. If I have 8 units and I subtract 2 units, then that leaves me 6 units. And that's the result we got with algebra tiles as well. So again, let's think more abstractly. I have a minus in between my groups, so I want to change that minus to a plus, which I can only do if I change the sign of every term in the following group. So instead of negative 3a, now I have a plus 3a. Instead of plus 4, I have minus 4. Now I can drop the parentheses since I'm adding negative 3a cubed plus 5a squared plus 4a minus 5 plus a positive 3a is just plus 3a, and plus a negative 4 is just minus 4. Now I'm ready to look for like terms. I see that I only have this one term of negative 3a cubed. There are no other a cubes in the list. If I look for a squares, I only have the 5a squared term. Now when I look for a terms, I have 4 a's right here and another 3 a's right there, so altogether that's 7a. And then for numbers, a negative 5 and a negative 4, which gives me negative 9 altogether. Turn your paper over and try these examples. Pause the video and then come back and check your answers. Make sure you try these on your own before you continue with the video. Now that you're back, check your answers carefully. If you can't find mistakes that you made, then make sure that you ask about them now before you go further. Let's look at our last example. Find a simplified expression for the perimeter of the polygon. Remember, a perimeter is adding up all the edges. So I can start on any edge and then just add the edges together. 6a plus 2a minus 6 plus another 6a plus a 2a minus 6. Now we want to combine the like terms. So 6a plus 2a is 8a plus 6a is 14a plus 2 more a is 18a. Then we can add our numbers. We have a negative 6 and another negative 6, which gives us minus 12. So this is a simplified expression for the perimeter of the polygon. You have a few practice problems below, so make sure you do those and check your answers on Google Classroom before you do your mastery check.